All right, so today, solving percent increase and decrease by writing an equation to represent the situation and then solving it. Okay, so paying interest, okay? Paying interest is paying a charge for borrowed money. So like you pay interest on a loan, you pay interest on a credit card purchase. You can also collect interest when you're in a savings account. So that's a good. So interest can be good or bad. It just kind of depends. Okay. Depreciation is the decrease in what something's worth. So once you buy a car, the value of your car depreciates over time because your car gets older, it's worn, it has more miles on it. There's new cars that come out. So the value of your car goes down and down over time. So it's depreciation. Okay. All right. So we are going to solve the problems on page 169 and 170. I would like you to try to solve these on your own and then watch the video. So my hope right now is that you pause the video, solve them, and then come back and watch, or do one at a time. It doesn't matter to me, but I would really like you to do that first. Okay, so now that you solved it, we're going to see what the answers are. So it says money in particular savings account increases by about 6% after a year. How much money will be in the account after 1 year if the initial amount is? So that's a percent increase. So I have my 100% plus my increase is 106% of the original amount. As a decimal, that is 1.06. So if I'm looking for how much money is going to be in the account, I have 100 times 1.06, which is $106. Here I have 50 times 1.06, which would be $53. I have $200 times 1.06, and that's going to be $212. 125 times 1.06, and that's going to be $132.50. Please do not put 0.5. This is money. Okay, and you should have all of this work. If you don't, you need to add it in. So then it's wondering, like, what is my repetition? So this changes. That's the variable. So that's the x. This is the constant. So it'd be 1.06x. 1.06 times the amount of money. Okay. All right. Number 2. The value of a new car decreases by about 15% in the first year. How much will a car be worth after 1 year if its initial value is? Okay, so same thing. Please solve this question and then come back for the answer. All right, so decreases. So I have 100% minus my percent decrease. So you will be paying, your car will be worth 85% of what it was originally. Okay, so I have my $1,000 times my 85%. Okay, which would be $850. Double check my math here. Yep. So then I have $5,000 times is going to be, your car will be worth $4,250. And 5,020. These are pretty cheap cars. Equals $4,267. $8 So what is my repetition? Where my variable is here, my constant is here. So there's my percent of the original price times the value. Okay. Number 3. So 5.3, match an equation to each of the situations. Be prepared to share your reasoning. Obviously, you won't have to do because we're not going to go over this in class. You're just doing this on your own, but you can talk with a neighbor if you'd like. The water level in a reservoir is now 52 meters. If this was a 23% increase, what was the initial depth? Okay, so number 2, the snow is now 52 inches deep. If this was a 77% decrease, what was the initial depth? All right, so I would like you to try to answer these and then come back for the answers, please. All right, so you need to think about what are we looking for? We want the initial. We're looking for 100%. So 52 is the 23%, which means when we had the original amount, we took away, okay, or added the increase. So it was a 23% increase. So 52, that is equal to the 1.23 times whatever my initial amount was, because we added the 23. So this is 123%. Okay, so that is equal to 123%. Well, let me go back. All right, so in order to solve that, we're going to solve for x. So, here, right here. Sorry, I wasn't even paying attention. Okay, 123% times the original depth is going to be 52, and it should be less than 52. So you can go back, you can always check. Okay, now the snow is now 52 inches deep. If this was a 77% decrease, what was the initial depth? The initial depth is going to be way greater. Wait. This was so this is a decrease. This is an increase. Oh my gosh, you guys, I'm backwards. Pause, stop, rewind, start over. Lo siento. This is the increase. So 52 is equal to, oh yeah, no, that's right. Okay, no, I was right. Sorry. I don't know what I'm thinking. I was right. Okay. Decrease, 77% decrease. So 100%, the decrease. I don't know what I was thinking. I second guess myself again. You guys, I do it all the time. Even, see this again, with Mrs. Edie, you get live, real time mistakes, thoughts. Mr. Morgan, you get just all the right answers the first time. So 100% minus 77% is the 23%, which means that this represents 23% of what it was originally, right? So that would be this one. 23% of the original is going to be 52. I was trying to think of like the answers. No, the answer is going to be bigger, but no, this is bigger. We're good. We're good. Because this is more. This would be less. So there you go. Here goes here. Here goes here. If you have questions on it after, let me know. I'll reiterate quickly. I mean, I did the work, so hopefully you had that before I erased the page. The initial depth is going to be less. And when I dividing by greater than 1, so my answer is going to be less than 52, which it should be less because this is an increase. Now, this is a decrease, right? So if I divide by less than 1, my answer is going to be much larger. Because if 52 is only 23%, your answer is going to be over 4 times bigger, right? Which is right. Because that's a decrease. So my original should be more. I don't know what I was thinking in my brain. I'm so sorry. All right. Again, you get real life me. 5.4, representing percent increase and decrease, the gas tank in Dad's car. So this is, this is what we did yesterday. So I'm just going to reiterate this really quick because this is what we did on the paper yesterday, and we already talked about the equations. So the equation, 50% more. So the amount moms holds is 1.5 times dad's. Decrease the popcorn bags. We did the t-shirt. You can look at all the stuff from yesterday on your handout. Eraser, clear. Why isn't this working? Mouse. There we go. Did that one. Oh, we wrote equations for all these. Perfect. So that's the lesson. Easy peasy, lemon squeezy. So you can go through, and then your homework is right there. Right there. So I will see you all tomorrow or